Okay, so in this second part, so we are going to assign the frame section in this model. So in this last class, we have prepared this model. This is only just, line. So there is nothing, any frame here. If you go to this tab and click structure and full section, so you will see nothing here because there is only lines. Okay, now we will assign the frame at that lines. Okay, so to do that, we have to go to general tab. Okay, and then we have to click on property tab. Okay, so here you can see these columns are tapered. Okay, these columns are tapered. Okay, this one along the this line and this line, these columns are tapered. Okay, so first of all, we take a tapered column. Okay, initially we will assume, and then after design we will finalize. Okay, so we will start from tapered eye section. Okay, so here you can see the section here. So what is the F1 and F2? F1 is the depth at the first point, and F3 is the depth at the second point. Okay, so here if you see this column, okay, if you see this column, so this one is first point. Okay, this one is first point, and for this column, this one is the second point. Okay, so now sorry, so now we click define and go to tapered section. Okay, initially we start from 300 at the bottom. Okay, wave thickness, F2 is the wave thickness. Let's take it 8 mm. Okay, and at the top is 0.9. Okay, we can customize this later after design, no problem. Okay, we take flange 250. Okay, 250, and flange thickness, okay, 12 mm. Okay, okay, then we will add this one. Okay, close. Then we will select, go to the beam cursor and select these ones, all the columns. And just assign. Look, assign to selected beams. Okay, these are selected, so we can select these two. Okay, just select this line section, right, and then assign. Okay, now you go to this structure, this tab, and see the structure. If you see the full section, now you can see the tapered section of the column. Okay, okay, then we will assign property to this line. Okay, so then go to define, then again tapered section. At the end frame, okay, at the end frame, the section will be homogeneous. Okay, so let's take 300. Okay, 300 of wave 8. Okay, that is 250. Okay, 250. Okay, and 10 mm. 10 mm is the flange thickness. Okay, then assign. Then click here. Okay, close it. Then click here, 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 and here, and then okay. You can rotate this section. Okay, you can rotate this section. Okay, you can rotate this section. How to rotate? Okay, then you go to beta angle here, create beta angle. Okay, you just put 90 degree here, and then okay, okay, then select this beta 90, and then again select this material too. Okay, just select, control and select. Okay, Control tab and select all the material you want to rotate, okay, and then assign. Okay, now the columns has been assigned. Okay, column has been rotated. Okay, here you can see, you can rotate it, and you can see the column has been rotated, you know, along its major axis. Okay, okay. Now, we want to assign rafter size. Okay, so to assign, again go to section. So go to rafter, again define, again rafter section. So start from here. Okay, so start from 900. Okay, sorry, start from 900, and it's at the end it will be 400. Let's take 8 mm. Okay, 200. I am just taking, we can customize it later, no problem. Okay, 0 and okay. So 900, 8 or 200 is the flange width, 10 mm is the thickness. Okay, then add this one. Okay, then again for the second part we will take 4. If you go to the section, you can see first part is a tapered one. Okay, first part is a tapered one. Okay, and the second part is straight one. Okay, homogeneous, and the third part is homogeneous again. Okay, so then add this value. Okay, then we can reduce it to our necessity. Okay, then add this one, turn it. Okay, so this is our first part. So select this ones, this ones, this ones, okay, this ones. Swans. Yeah. Okay. Then assign. Look, this tapered section is only assigned to, you know, mid frame. Okay. Then this frame, select this one, this one, this one, this one, this one. You can rotate for simplicity. Okay. Select, rotate more. This one. Okay. Then assign. Then you can assign this section. Okay. Then if you want to do it quickly, you can do it like this way. You select. Let's go to 3D model and check. Yes, these two are missing. Tap control and select. Okay, then assign this one. Okay, here you can see your rafter is completed. Okay, your rafter is completed. Okay, now we will assign rafter of end frame. Okay, so end frame is you know, homogeneous. Okay, so then go to define again rafter. Let's take it 200. Okay, 5 and 200. Okay, and 200. Also the flange thickness, flange width actually, and 8 mm is the, you know, flange thickness. Okay, So 200, 200. Okay. So this is how you can put your value, then add here. Okay. And then assign. Okay. Assign. Sorry. Probably there is any mistake. You can see it has 8. So then change. Okay. All right. So the end frame has been assigned. Okay. Now we are going to assign our bracing member. So as we have considered it is a cable bracing or rod bracing. So we go to define, okay, and use kind of circle, okay, probably material steel. So if we consider it a rod bracing, say the diameter of the rod is 20 mm. So okay, 20 mm, then add it. Okay, then select all the member. Okay. You can rotate your convenience. Okay. So all the bracing member have been selected and then assigned. So your bracing member have been assigned. Okay. Now we are going to assign our start member. Normally start members are pipe or box. Okay. So you can you can assign box from, sections. Okay. If you go to sections, you will see, a box section. Here is a tube. Okay. So these are, code preferred. Okay. Or code based. If you want any customized size, then you should go from here, go to tools, then create user table. Okay. Suppose I will, assign pipe as a start member, then go to new table. Okay. You just go to, pipe. Okay. Okay, then add new property, just give a name, strut. Okay, so what is the outside diameter? Say 110. Okay, and inside diameter is 100. Okay, and then click OK, then close. Okay, then go to here, user table. Okay, this is one. Okay, one. If it is start member, then add it. Then you can see the start has been added. Okay, then select all the start members. All the start member has been selected. Select all of them. Okay. Okay, this one, this one, this one. This one is also some start member, the end bay. So select this two. Okay, so and sign. Okay, now you can save it. Okay, so start member has been assigned. So all the steel members has been assigned. Okay, now we will go to our RCC portion. Okay, so to assign RCC portion, first of all, we will assign grade beam. Okay, so to assign grade beam, then we go to define. We need a rectangle section. If you see, YD is vertical and ZD is horizontal. Okay, so ZD is width and YD is the depth. So let us consider a grade beam of 300 by 600. Okay, so 600 is the depth and 300 is the width of the grade beam. So your material is concrete. Okay, then just click OK. Okay, now we can select it easily. Just select here. Okay. Okay, you can see all the grade beams around the periphery of this shape has been selected. Now just put assign. Okay, look, all the grade beams have been assigned to here. Okay, now we have columns, RCC columns to be assigned. Okay, now we can assign. Look, what is the size? What is the size of the RCC column? So in case of RCC column, you have to calculate. You have to calculate the preliminary size of the column. Okay, preliminary size of the column. Look, you have 300 here. Okay, 300 at the bottom of steel column. Okay, so if I go to any, look, this is your steel column. Okay, steel column. So you have considered 300 and this one is 250. Okay, this is column. Now, after steel column, there will be an base plate. Okay, there will be an base plate. Okay, after base plate, there will be an RCC column. Okay, this is just preliminary calculation. Okay, so if you have 300 here, then from your column, your base plate is 75. Okay, and from base plate, your steel column outline is 75. So 75, 75, 150. Here is same 75 and 75. So here is 150 total. Here is 150 total. So your steel column is 300. Okay, plus this side 75 plus 75, 150, and this side you have also 150. Okay, so what is the value? The value is 600. So the width of your preliminary RCC column, sorry, actually the length of your RCC column will be 600. Okay, if you have any brick wall, okay, or masonry wall going through your RCC column, then you will have to also add the width of this, brick or masonry, work. Okay, so for the time being, we just consider 600 is the length. Okay, and what will be the width? 250, again 75, 75, 150, again 75 from steel column face to base plate, and base plate to RCC column is 75. So 250 plus 150 plus 150. So that means 550. Okay, so your preliminary column size is 600 by 550. Okay, for these columns. Okay, so let's just take a column, define rectangle. Okay, 600 and 55. Okay, add. Then just select. You can select from here to okay. Select, you can see that selected here, this column, this line too. Just select manually this. Okay. Select the corner columns. Corner column size will be more larger. Okay. So just assign this value. Okay. Here you can see your column size here. Okay. So 600 is the length. So 600 is the length. Okay. You can check how you can check it. You can go where you can select your this column, your RCC columns. Okay. View shows selected objects only, and then go to 3D. Sorry, view shows selected objects only. So only the RCC column will be. If you go to the top view, you can see. Okay, you can see your column size. Okay, you can see your column size. Okay. All right. So preliminary, you have to calculate roughly the column size, but after the design of base plate and anchor board, your final RCC column will be finalized. Okay. So preliminary, we will assign like this. Okay. After that, okay, we will assign this column. So this column size is, I just check it. It's 300. Okay, 300. So if 300, then we just take, rectangle 600 by 600 column. Okay, add. Okay, and then add this. Sorry. Assign here. Here. Okay, so this is the N by RCC column. Now we have only remaining the corner column. Normally the corner column size is larger because you can see here, if this is a corner column, okay, if this is a corner column, okay, corner RCC column, so your wall is coming from this side, okay, and that side too. This is your masonry wall. Okay, this is your masonry wall. So normally the column size at the corner will be much more than others column. Okay, so for the time being, we just assume that the column size of the corner is 800 by 800. Okay, or it may be 700 by 700. So we'll start with 800, then we can change it later, no problem. So the design, then we just assign here, assign here, assign here, assign here, assign here. Okay, now we will assign this here. Okay, now we can see the all the properties has been assigned. If you go to select and check it here, missing attribute, missing property, no, there is no missing property. So all the lines that we have drawn in the previous session has been assigned with a frame. Okay, this is the preliminary frame. We can change it after design. We can change it, no problem. So this is how you are going to assign. You are going to assign your frame to your member. If you need this columns, this RCC columns larger, then you can go here. You can go here. You just simply put, say, 800. Then just put 800. You can see your column has been enlarged. Here you can see your column has been enlarged. So for the time being, we just consider it is at 700. Okay, we will finalize after our design. Okay, so this is this is the process through which you can assign your frame to the model. Okay, now another thing we have to do to release or assign property. So to do that, we have to go to specification. Okay, specification. Look, we are going to design this joint. If we consider this, and we are going to design this joint as a pin support. Okay, this joint as a pin support. Clear? So what we are going to do, we are going to go to beam and then release. Okay, start release, because this is the starting point and this is the end point. Okay, so it's starting release. So we will not do full release, we will do the partial release. So partial release, and what will be the partial release? Say 98 to 99%. Okay, then MP means X, Y, Z, all three of them will be covered. Okay, then add. Okay, then you just click these members. Okay, for the simplicity, I just take these ones. Okay, you can write this way. Can write this way, can write this, can select this way, no problem. Okay, then you just put some value. Here you can see the moment has been released here. So this joint will act as a pin support. Okay, this joint will act as a pin support. Okay, at the end bay, normally we design this joint at the end bay. Actually we prefer to design this as a pin support, these joints. Okay, so then again we go to beam, then again partial moment release, but this time it will be end. Okay, so this is the end point. Okay, then again go to MP 0.98. Okay, then add this one. Okay, then click this value, then click this end frame members. Normally we try to design with pin support, but you can go with fixed support, no problem. Okay, no problem, you can go with fixed support. Okay, here you can see this column, at the start point it is pin support, and at the end point it has also pin support, but this column has pin here but fixed it this point. This point is fixed. Okay, this is how we are going to design. You can fix it to this point too, no problem. Okay, then we have cable bracing or rod bracing. Okay, so if you have rod bracing or cable bracing, then go to beam and make this member as tension only. Okay, so this member will not take any compression. So go to tension and then add. Okay, then select the member tension and then select, go to specification, property name, go to this one. So all the members will be termed as a tension member. Okay, all the members will be termed as a tension member. Okay, now here you can see your start member. These are your start member. This start member will also have a pin support at both ends. Okay, so then we will go to select. And then select start member. All the start member has been selected. First of all, we start with MP3, and again we select end MP, and then again with assign. Okay, you can see all the start member has been pinned at both ends. Okay, all the members has been pinned at both ends. So this is your how you are going to assign the member or specification to your member. Okay, in the next class, okay, we will discuss about the vertical loads. Vertical loads mean dead loads and live loads of this building, and how we are going to put this one. Okay, so for the time being, thank you for very much. Okay, and please do subscribe if you like the video. Okay, thank you.